Starting off, we are going to first of all talk about units. So, what are units? Before talking about units, let's know about a unit. So, a unit is a standard, it is a standard reference chosen to measure a physical quantity. So, basically, units are standard reference. So, these are the standard that we take as reference. So what is a reference? And another good question would be, what are physical quantities, or what is a physical quantity? So let's take an example. Suppose I write 1. You don't know what 1 means. It might mean length, a number, a quantity, we don't know. But when I put centimeter across it, you know what it is. It's a length. It might be a length of a rod, it might be a radius, it might not be a diameter, but it's a length. So units, which is cm in this case, gives us what the physical quantity is. So the standard reference used here is centimeter, which is also written as cm. So this is unit. This is a unit. And the combination of units, for example, I can write centimeter, meter, kilometer, or I can even write second, hour, or for we can do others as well. So this will be considered as units. Now let's talk about a good question that we had, which was, what is physical quantity? So physical quantities, now we are going to talk about this. What are physical quantities? So let's write my topic, which is physical quantities. This is just a shorthand being used by me to write a little bit faster. So physical quantities, when we have to define it, we have to define it by any property, any property of a system, any property of a system that can be measured and expressed as a number with a unit is known as physical quantity. So we already talked about physical quantity. The physical quantity that we talked about was 1 centimeter right over here. So this 1 centimeter is the physical quantity that we were talking about. So why are they called physical quantities? We have to talk about that. So think about a rod. I'm taking the most simple example. Think about a rod. Suppose this is a rod, okay? So when we take about this rod, what can you describe from this? You can describe its mass, which we will talk about later, which I can write it as m, or I can describe its length. So the length can also be from different places. It can be from the center to the edge. So this would be from center to the edge, or we can go from edge to edge, or we can go 3/4 from edge. There are many ways to do this. But it still gives us the length. Okay, so these are the physical quantity that we are talking about. Now, since we are talking about physical quantities, we have to know how to describe them and the varieties that they are found in. So let's talk about types of physical quantities. So the next topic we are going to talk about is types of physical quantities. It's supposed to be quantities, but I'm just writing quantity because it is my shorthand. Okay, so there are two types of physical quantity, number 1 and number 2. The first one is known as fundamental quantity, and the second one is known as derived quantity. So a fundamental quantity will have itself a fundamental unit, and a derived quantity will also have a derived unit that goes along with it. So first of all, let's learn about the fundamental units or quantity. You can describe them in any way or you like, because for let's make it simple. Okay, if I write 1 centimeter, if we're talking about a fundamental unit or units, let's talk about unit. It will be this centimeter, and the physical quantity will be this 1 centimeter. Okay, so now let's move on to the next topic, which is fundamental quantity or fundamental units. I'm going to explain through fundamental units because a fundamental quantity is just a number with the fundamental unit. So if you understand fundamental unit or derived unit, we will understand fundamental quantity and derived quantity. So let's talk about fundamental units, or which is also known as base units. So I'm writing base in brackets so that you know it is also called that. So you can to understand this, they are directly defined, okay, some properties which will help you to understand it, and they are not dependent on others. So we will take I will understand this, I will teach you this when we get to derived units, because it will be much more easier, okay. So also let's write another quick point. For example, a fundamental unit or a fundamental quantity is time. We take second as a fundamental unit of time. So the time or second is defined by atomic clocks using the vibration of cesium, which is an element, cesium 133 atom. So the second is defined by a cesium 133 atom, okay. So now let's talk about derived units, then I will explain fundamental and derived units together. So when talking about derived units, it's pretty similar but exactly opposite. Not opposite, but let's say it's very if you understand one of them, you can understand the other one. So when talking about derived units, they are formed by combining fundamental units. Fundamental units. Okay, let's understand them. I will tell you two fundamental units. We will also talk about them later, but let's talk about them right now. The fundamental unit, which I'm going to write as FU, fundamental unit of length is meter. So I'm just going to write meter for M for meter. And the fundamental unit of time is second. Okay, so you can write for meter, I can write like 1 meter, 0.5 meter, or any amount, any number with a meter. So I can write a number as n and meter as the unit. So let's write it with another color so that it becomes clear. Okay, so I'm going to do like this. So any number along with its unit. Okay, same as for second. So I can write it as, so any number with a second behind it will give you a fundamental quantity that expresses time. Okay, so let's take a derived quantity, which is velocity, which is represented by v with the arrow, but I'm not going to represent the arrow right now. Or speed will be the velocity without the arrows, but so I'm going to represent the arrow, but I don't need to, so I'm not gonna. Do you get what I'm saying? So I will explain why we need the arrow and why we don't need the arrow when we come to vectors, which is not right now. So let's get the gist of it right now, okay? So when writing this, we would write this as displacement over time. The displacement should also have an arrow, but I'm not going to write it right now, okay? So here, displacement is length. So you would measure it in meters if you were considering a SI system, which we will talk about later, okay? And also, the time will be measured in seconds. So for example, let's say a car moves 1 meter in 1 second. That would lead you to the 1 divided by 1 leads to 1, and meter divided by second leads to meter per second or meter per second. Both are same. Okay, but here, as you can see, there are two fundamental units being used. One is meter and another is second. That's why velocity is considered as a derived quantity, which means meter per second is a derived unit. So I think you understood what I'm trying to say. Okay, so now let's talk about systems of unit. Okay, system of units. So system of units. So we use various systems I'm just gonna talk about the most popular. Okay, so number one is CGS system. So what occurs in CGS system? The CGS system uses centimeter, gram, and second. So let me, gram per and second. The full form also you can write it out. The centimeter will be centimeter, gram will be gram, and second will be second. So it's not necessary to write them out, but I'm still gonna write them out if you need it. Okay. The short forms are also there, and the full forms are also here. This next one, which is a very popular one, is called FPS system. FPS system. And here, centimeter, gram, and second are the fundamental units in CGS system. Okay. In FPS system, the fundamental quantities are foot, pound, and second. So foot can be represented as FT, pound as LB, and second as S. So I actually wrote them backwards, but never mind. You get the point. The third one, which is MKS system. Okay. So when talking about the MKS system, we have three of them as well here, which is meter, kilogram, and the second. So here it will be meter, kilogram, and second. So most people in America will use the FPS system, while other countries use MKS system. And we use MKS system here, so it is much more easier for me to understand the MKS system than the FPS system, because the algebra is much easier to do in MKS system than CGS system. By the way, you know that I'm stalling time, right? Because I'm like kind of fixing this. So let me fix this pretty quick, then we will get back on topic. Okay, now the last system, which is kind of important, is the SI system. So SI system is like the golden standard of system that most of the world and the scientific community uses. Okay, so this is the modern system. So let's just write modern. So it is an international standard. It means that it is followed internationally. Okay, international standard, and is used worldwide. Used worldwide. Now we will talk more about SI system pretty quick, but before that, let's talk about why, why only these 4 units and why only them. Of course, there are more units, but why are we using these system and why are we highlighting these system? The simplest reason is because they are good units. They have good units. They work very well. So let's talk about good units. Good units system. Good unit. Sorry, I wrote units. It's supposed to be unit. Never mind the English. Okay. Good unit system qualities. So the following are the good unit system qualities. Number one, which is universally accepted. So they must be accepted by the universe or the earth, people in earth, basically. For example, if I said, bring me one liter water, and the guy brings a truck full of water, then that will be a big problem, won't it? That's why it must be universally accepted. When I say 1 liter, everyone must understand what 1 liter means. Okay. Another one is invariable. Okay. So if I have a gold bar that weighs 1 kilogram today, it can't be so that it weighs 17 kilogram the next day, because that would cause huge troubles. Okay. And the third one is easily reproducible, which means that suppose I say 1 kilogram, it is pretty easy to reproduce, which means the experiment or the logic behind the unit is very simple and easily understood. It may cost a lot to reproduce, but it's pretty reproducible. Okay, so suppose I take 1 kilogram. Every single 1 kilogram bar may not be exactly 1 kilogram, but it can be pretty close to it. And if you want the exact 1 kilogram, you can also find it. Okay, that's what it's mean by easily reproducible. So it can be by equations and many more. And the other one is convenient for calculations. That's why the SI system or the MKS system, MKS system, SI system is kind of derived from MKS system. So that's why I'm relating them. So they are very easy for calculation because they use tens, power of tens, which makes it very easy for calculation. So now let's move on to SI unit. So SI unit, the things that you must consider is that there are 7 fundamental units along with 2 supplementary units. Okay, the supplementary units are also derived units that we talked about. Them, but supplementary units are kind of special, so we are gonna mention them as well. So first of all, let's talk about the 7 fundamental units of quantities. We are gonna compare the quantities along with the units. So 7 fundamental. Should I write quantity or unit? I'm gonna write both, quantity / unit, to make it easier. Okay, so I'm gonna kind of make a table. So here let's put the quantity, here let's put the unit, and here let's put the symbol. Why the symbol is important is because it's very repetitive. It's not easy to write all of them. They are kind of long. So for example, let's take the first one. The first quantity is length and its unit is meter. Suppose you had to write meter for every one of them. It would be very difficult and very boring. That's why we use symbols. So the symbol of meter is M. The symbol of meter varies on the basis of the dictionary that you use. It might be also written as METRE, but I will generally use METER. You can use any one of them. Both are fine on the basis of which English are you using. Okay. So the mass, it's measured in kilogram. So kilogram is written as kg. Now the third one is time. Okay, let's write 1, 2, 3 as well. So 3, time. The third one is time, which is measured in second and written as S. I think you're pretty familiar with meters and second because we also talked about them when discussing about derived units when I was talking about velocity. Okay, the next one is temperature. Temperature, which is in Kelvin. Okay, and its symbol is capital K. It's not small k, it's capital K. So these are the most common fundamental units that you will see, but there are 7 of them. So let's write the other, I don't know, 5, 6, 7, 3 of them. So let's write quantity, unit, and symbol. Okay, so first, I don't know, where was I? 5th. The 5th quantity is electric current. Electric current. The electric current is measured in amperes or amps. You will also, the layman word of is called amps. You might hear that electricians say 10 amps, 20 amps, 30 amps. So that's what they are talking about. The next one is luminous intensity. The 6th one, luminous intensity. Its unit is candela and its symbol is capital C and small d. 7 is quantity of matter. Quantity of matter. So quantity of matter is defined, its unit is mole, MOLE, and its symbol is MOL. So it just removes the E. So now let's talk about supplementary quantities because I said they were also quite important. So there are 2 supplementary quantities. Supplementary quantities, and they are actually derived units. Don't forget about them because they are defined. They come from a formula, so they are derived units as well. So let's write the quantity, the unit, and the symbol. Don't worry about me explaining these. I will explain them in a new video that will come out pretty quick. So check out for that. The first one is plane angle. So this is the symbol for angle for me. Plane angle is in the units of radian and its symbol is RAD. The second one is solid angle. Solid angle and its unit is steradian. Steradian and is SR. You can write radian as capital R or small r, doesn't matter. So this much for today's video, and in the next video I will explain all of these units. Thank you.